Number 14, find the integral. So we're looking for an indefinite integral. When you're working with these, the first thing you want to ask yourself is whether or not you need to use substitution. So for this one here, we do not. We can just take the antiderivatives term by term. So the first one I have 4x. Remember, we add 1 to the exponent and then divide by our new exponent. Minus 7x to the 4th over 4 plus 6x and then plus c, some arbitrary constant. And we do need to simplify our coefficients. So 4 over 12, so I get 1/3. X to the 12th minus 7/4 x to the 4th plus 6x plus c. And that's my answer. Another way you could write your terms here, you could, if you wrote it as x to the 12th over 3, that's fine. Minus 7x to the 4th over 4 plus 6x plus c, that's fine too. For number 15, again, we're looking for an indefinite integral. And the first question always, do I need to use substitution? I can simplify this one first algebraically. So go ahead and use algebra first. I'm going to break it up. Since I'm dividing by a single term, I'm dividing by a monomial. I can go ahead and separate this. So I get x to the 5th over x plus 1 over x. And then I'll reduce these fractions. So I have x to the 4th plus 1 over x, or if you prefer, x to the negative 1. All right, and then I can go ahead now and find antiderivatives term by term. So in the first one, I'm using my power rule. So I add 1 to the exponent and divide by my new exponent. And then the second one, if you try to use your power rule, so you got x to the 0, and then you divide by 0, because we know we can't divide by 0. So that's another way of helping you remember that it must be the natural log rule. So it's the natural log of the absolute value of x. And we have our plus c. And again, this first term, if you want, you can write it as 1/5 x to the 5th plus natural log absolute value of x plus c. Once again, we're asked to find an indefinite integral. This time I am going to have to use substitution. If you notice, it's a much more complicated function. I have, a bunch of stuff here raised, to a power. So like I said, I can think about, reducing the fractions or doing something with it. But once you see stuff raised to a power, you're going to be stuck with substitution. Okay, so the first thing I need to do is figure out what I want my u to be. And like I said, I see all this raised to the 4th power. To me, that's kind of obvious as my u. Some students like to rewrite it first. So if you want to bring that up first, that's fine as well. So I'm going to go ahead and bring that up. So I have 3 plus x to the 7th raised to the negative 4th power, because I brought it up. And then my 7x to the 6th dx I've left alone. Okay, so again, I'm going to let this be my u. So there we go. So that's going to be my u. So my u is equal to 3 plus x to the 7th. Now I can choose whatever I want for u, but then I'm stuck with the du that goes with it. So now I take the derivative of this, and so du is going to be 7x to the 6th dx. And I had to substitute in for both u and for du. So I know I've already got u to the negative 4th, and then the 7x to the 6th and the dx, all of this together is equal to du. And I've got that, so I don't have to do anything else. On some of them we have to fix them, tweak them a little bit, so that'll be another example. So now substituting in, I have u to the negative 4th du. And now we use our power rule. So I add 1 to the exponent and divide by my new exponent, plus c. So I have a negative 1/3, whatever my u was. So it was 3 plus x to the 7th. And this is to the negative 3rd power, plus c. I'm happy with you writing it like that. You may see it, especially if it's multiple choice, where they will bring this down since it's a negative exponent. So 3 plus x to the 7th to the positive 3rd is in the denominator. Okay, so like I said, either one of these last two is fine. Okay, we have another definite integral. If I have just e to the x or e to the t, I can take the antiderivative using my basic exponential rule. But I have e raised, to the stuff. So I'm going to have to use I'm going to have to use substitution. So u is going to be 7x plus 4. And when I take the derivative of this, I'm stuck with the du is equal to 7 dx. Okay, so I have to make both substitutions. Now the problem on this one, I've got the u there, but I don't have the du. I need a 7 and a dx. If I'm only off by a constant, I can fix that. So I'm going to go ahead and put in the 7. So I'm going to multiply it by a 7 here. But so that I'm not changing it, I also have to divide by 7. So 1 over 7 times 7, that gives me my 1. So if I put the 7 in, I always got to put the 1/7 out there. So now, though, I have my 7 and my dx. That together gives me my du. So I have my 1/7. And then the e to the 7x plus 4 becomes e to the u. And then the 7 dx is replaced by du. And now I can take the antiderivative. So I've got 1/7. The antiderivative of e to the u is e to the u and plus c. And then don't forget to substitute back in at the end. So 1/7 e to the, my u was 7x plus 4 and plus c. Remember, you can always, check your antiderivatives by taking the derivative. If you use substitution, then think about using our chain rules, our general power rule, general exponential rule, stuff like that. There is another separate video on integration or antiderivatives. You can find that one. I go through about 10 examples, and about 7 of them use substitution. So if you'd like to see a lot more on substitution, go check out that video. Find the particular solution for the differential equation y prime equals 4x plus 7. We're also given that y of 3 is equal to 27. So here I'm asked to find a particular solution. That means when I take the antiderivative, I get this general solution with the plus c. The particular solution, I have to solve for c. And that's what this information in here is going to help me do. Okay, so my first thing is I have to find the antiderivative. So y is going to be equal to, y prime is equal to 4x plus 7. So when I take the antiderivative, y is going to be equal to, I add one to my exponent, divided by my new exponent, so 4x squared over 2, plus 7x plus c. And I'm going to clean this up, so y equals 2x squared plus 7x plus c. So this is what I have right now. Like I said, this is my general solution. And I'm going to use this information to find the particular solution. So notice that y of 3 is equal to 27. So y is equal to 27 when x is equal to 3. So I'm going to plug that in here. So I have 27 is equal to 2 times my x is 3, so 3 squared plus 7 times 3 plus c. Now solve this for c. So 27 equals 3 squared is 9 times my 2, so I get 18 plus 21 plus c. And this will give me 39 plus c. And then subtracting 39 from both sides, we'll end up with c is equal to negative 12. Okay. So that means my particular solution is going to be y equals 2x squared plus 7x, and now that I know what c is, minus 12. And that's my particular solution. The rate of expenditure for maintenance of a particular machine is given by m prime of x equals 12x square root of x squared plus 5, where x is time measured in years. Total maintenance costs through the second year are $105. Find the total maintenance cost function. Okay, so I'm asked to find the maintenance cost function, and I'm given the rate of maintenance. So my maintenance function, so maintenance, is going to be the antiderivative of the rate of expenditure of maintenance. Okay, so I have m of x is equal to the antiderivative of 12x. Then I got the square root of x squared plus 5. All right. I know I'm going to have to use substitution for this one. All right, so I'm going to go out the side and use my substitution. Think about what you should pick for u. So since I have, stuff underneath the square root, I've got x squared plus 5 to the 1/2 power. That's going to be my u. So u is equal to x squared plus 5. That means du is going to be equal to 2x dx. All right, so my u is already there. I don't have my du. I need 2x and I have a 12x. So there's a couple ways of doing this. If you look at 12 and you say, hey, I can just split it up as a 6 times 2x, by all means, you can do that. Let me write this in here. So I got, that's 6 times 2x. And then what I'll do is, since I don't need the 6, I'll pull that out front. And I'll leave my 2x inside. And so now my u is right here. And then my du is the 2x and the dx. Now I'll make that double substitution. So I've got 6, the antiderivative of u to the 1/2 du. Okay, now when I take the antiderivative, let me come this way, I get 6, I've got u, I add 1 to the exponent, so 1/2 plus 1 becomes 3/2, and I'm going to divide by 3/2. When you're dividing by a fraction, it's, I always think of multiplying by the reciprocal, so it's times 2/3. And then we still have our plus c. So cleaning up my my coefficients here, 3, I get 12 over 3, so I get 12 over 3, I got 4, sorry. So I got 4u to the 3/2 plus c. So where I'm at right now then is m of x is equal to 4. My u, remember, I have x squared plus 5, so that's to the 3/2 plus c. So my problem is I've got this plus c, I want to find a particular solution. Keep in mind up here, I was told that the cost through the second year are $105. So my maintenance cost through the second year, $105. So when x is equal to 2, m is going to be 105. And so I can plug that in to solve for c. So I have 105 is equal to 4. And then again, my x is 2, so 2 squared plus 5 to the 3/2 plus c. And let's see, so we got 105 is equal to, inside the parentheses, I've got 4 plus 5, so that's 9. So 4 times 9 to the 3/2 plus c. 9 to the 3/2 is 27, so 4 times 27, I get 108. C, subtract my 108 from both sides, so c is going to be equal to a -3. Right, so now I know my c. So m of x is equal to 4 times x squared plus 5 to the 3/2 power minus c. And there is my maintenance cost function. Okay. So again, this one here, think of it as a particular solution. You needed to find a particular solution.